Hello and welcome to my talk, Cause of Death, Hibernate. My name is Thorben Janssen and I'm an independent consultant and developer specialized in solving Java persistence problems with JPA and Hibernate. If you have any questions during the talk, please post them in the chat. I will do my best to answer them. And if you have any questions after the talk, you can reach me on my site, thorbenjanssen.com, or via the Twitter handle that you can see here on the slide. Okay, before we dive into today's talk, I want to make one thing absolutely clear. You can, of course, use JPA and Hibernate to implement highly efficient persistence layers. That's what I'm doing in my day-to-day work. I'm helping teams to improve the performance of their Hibernate persistence layer. But following all the best practices and solving performance problems gets a little bit boring over time, right? I mean, who wants to only hear about what you should do? Why not take a different approach and break a few things and have a little bit more fun? So how could you get a project into really big problems? Well, very bad performance is always a good approach. Inconsistent results is something that all users hate. So let's take a look at that. And data loss is something that will keep your managers and CEOs up at night. So that's definitely also an approach that we could use to let a project fail dramatically. So let's start with bad performance and get into the IDE. Okay, the first thing I want to talk about is fetching of associations. So if we take a look at this test case here, I have a use case that fetches an author entity from the database. And then we have a log message that tries to access the books association on the author. And you can see it here, the test case failed. Why did it fail? It failed with a lazy initialization exception, because Hibernate wasn't able to fetch the books of the author here, because it's outside of the transaction in your application. That would probably be in the client, and the code that I highlighted here would run at the server. So when you call the getBooks method down here, the association would not be initialized, and Hibernate would try to get it from the database, but that fails outside of a database transaction. So why does that happen? Well, that happens because we have a many-to-many association here modeled on the author entity, and it uses the default fetch type, which is lazy. If you now search on Stack Overflow for this kind of problems and how to solve it, then unfortunately you will find the suggestion to use the fetch type eager. And well, as you can see, when I now run the test case, that will solve the actual lazy initialization exception, because, well, there is no lazy initialization anymore. But it introduces a new issue. And you will see that here, when I select all authors from the database, and I don't even use the books association. But because we use fetch type eager, we can now see that we executed 7 JDBC statements. And if I scroll up, you will see that 6 of them fetch the books of the authors. 1 query for each author that was returned by this initial query. Now, this is not a big deal in this small test database, but if you deploy that to production, you will for sure run into performance issues caused by the so-called N+1 select issue. And this is because we changed the fetching behavior up here for the author entity, or for the books association on the author entity. So fetch type eager here is actually a really bad idea. What would be better is to adjust the way that we fetch the author entity from the database when we actually need the books association. And then we can use a left join fetch clause, which tells Hibernate to initialize this lazy association. If we now take a look at the log output, you saw the test case passed. Now we have a query here that selects the author, joins it with the book author table, which is the association table of the many-to-many association, and joins it with the book. And we got all the information we needed within one query. And down here, we will not fetch the books anymore because, well, the association now is lazy and we don't trigger any fetching for that. Another issue that often occurs in projects and that actually makes it into production is modeling of too many associations using the wrong data type. So here I have a really simple example. I fetch a book entity, and then I get the first author who's written that book and remove it from the list. So we would now expect that there's exactly one delete statement executed by Hibernate that removes that specific record from the book author table, right? Well, unfortunately not. We have here a delete statement that removes all records from the book author table for the given book. And then Hibernate inserts the remaining authors, which in this case are 3. Where that not only looks a little bit strange in an audit log if your application writes one, it also creates performance issues if you have a lot of elements in that association. Why does that happen? Well, it happens because I modeled the authors association on the book entity as a Java util list. You can avoid this issue by switching this to a set, and then I need to change the getter and setter methods down here. And if we now run the same test case and take a look at the log, then we can now see that we just have one delete statement here that explicitly removes the record that links the author with the book, instead of removing all of these associations and reinserting the remaining ones. Okay, that's all about performance issues that I want to show you for now. So let's summarize this real quick. To avoid the most common performance issues, you should use fetch type lazy and query specific fetching, like using a join fetch clause as I showed you in the example. And please use a Java util set instead of a Java util list when you model many-to-many associations. The overhead of a set is way smaller than the overhead of all the additional SQL statements that Hibernate executes. The next way to get your project into huge trouble is returning inconsistent results. So how could that happen? So one thing that I see way too often in real projects is the following. You followed the advice that I gave you a few minutes ago and used the join fetch clause to initialize the association between an author and its book entities. And you did that in the query that is supposed to return all authors who have written the book with the ID 2. By using the left join fetch clause, you tell Hibernate to initialize the association, which means to fetch all the books that were written by that author, but only for the authors in this case that wrote the book with the ID 2. So if we take a look at the log, we now see that author Max Mustermann wrote book 2 and author Maria Mustermann wrote book 2. But if I now switch to the other query that you can see down here, you will see that the result of the previous query was incomplete. Why was it incomplete? It was incomplete because we used the join fetch clause here in the where clause, the join fetched association in the where clause as well. And that limited the list of books returned for that author to the ones that fulfilled the where clause. But that was not the intended approach of the query. We wanted to get all authors who have written the book with ID 2 with all of their books. And we only get that if we separate the join from the fetch join clause. So you can see now here that Maria also wrote book 3 and 4, and that Max also wrote book 1 and 3. So please make sure to use a left join for your where clause and a left join fetch to initialize your association between the entities. Another common issue that causes inconsistent results, or that can even cause the loss of update operations, is the management of bidirectional associations. When you're working with bidirectional associations, it's important that you update both ends of it. If you don't do that, like I do here, so I have the author entity, who is the referencing side of the association, and the book, who models the owning side of the association. And if I then go to my test case and remove the reference to the book from the referencing side of the association, then you would normally expect to see a delete statement that removes the record from the association table. But as you can see in the log output, there's a select statement, there's another select statement, a few more select statements. There is no remove statement. The operation here never happened on the database because we only performed it on the referencing side. So the right approach would be to also remove it from on the owning side of the association, which means we need to remove the author from the list of authors of that book. If you would only do this, so if you only perform this operation, but not that one, then Hibernate would actually perform the change on the database, but for the rest of your session, your author entity up here would be inconsistent because it would still contain the reference to the book. So if you update both ends of the association, you can see here that now we finally have the delete statement. But my recommended approach would be to not use these two update operations on the association and hoping that you never forget that in your application. My recommendation would be to implement a utility method like this one, remove author, which actually does the same thing as I did in my test case. And that in the end produces the same result, but makes your code way easier to maintain. Okay, so let's summarize the inconsistent results part real quick. I showed you should always separate your join clauses from the join fetch clauses and make sure that in your where clause, you only reference associations that you actually joined and not ones that you join fetched. Otherwise, your list of associated entities will be incomplete. And if you're working with bidirectional associations, it's essential to update both ends of the association. Otherwise, you either have inconsistent entities in your current persistence context until the end of your session, or even worse, the actual operation might never be performed on the database. Even worse than inconsistent data would be data loss. And there are not a lot of options or mistakes that can cause data loss with Hibernate, but there are a few. The most common one, and the one that I want to show you in this bite-sized talk, is the usage of cascade remove. Let's go to the author entity and activate cascade type remove on the books association. And let's do the same for the association on the book entity and run the test real quick. And then you will see that we perform way more data than we actually expected. What will happen here is we remove the author, then we cascade the remove operation to the associated books, remove all of these books, and for each of the books, we remove all associated authors. So if we have one or more books who have been written by multiple authors, we start on the author, cascade to the book, cascade back to the authors who've participated in that book, and then remove all the books for that specific author. So the remove operation is bouncing back and forth between the two database tables. And you can see that here we delete something from the author, from the book, another author, another book, another author, another book, and so on. There are quite a few of them. Well, I created this example in a way that we now have no records left in the book and the author table. It doesn't even help to just remove the cascade from the book entity, because what will happen now is when we remove the author, we still cascade the remove operation to the book table. And on the book table, Hibernate removes all the books associated to the author. And that is an issue if we have books that were written by multiple authors. So here I wrote out all the books written by author 2. And these are book 3, book 4, and book 2. You can see here author 2 is part of the author list. And then we remove author 1, and that here triggers a bunch of delete statements where we delete the author and all the associated books and the association table in between. And if we now scroll down to the log output, you can see that now only book 4 is left for author 2, just because author 2 wrote 2 of her books together with author 1. And we removed author 1. Hibernate removed these 2 books as well. And I'm pretty sure in a real application, author 2 wouldn't be too happy about that. Okay, there are other approaches or mistakes that can cause data loss with Hibernate, but the most common ones is cascade type remove. Please don't use it for many-to-many associations. Cascading is meant to be used with parent-child associations, and that is usually the case for many-to-one associations, or more precisely one parent to many children, but not for many-to-many associations. Okay, that's it for today. Before we end this call, I want to quickly tell you about my perf tester tool. It is one way, and I think the easiest way, to find and fix these performance problems, because it collects a lot of statistics while your test is running, and then tells you about the performance issues that actually happened during the test call, and not just about everything that could be wrong. And it will be released on this Friday, November 6th. You can find out more about it at thorbenjanssen.com/perf-tester. And I want to wish you a great rest of the day, and hope you enjoy the other conference talks. And it would be great if you would rate my talk on the official JFall app. Have a great day. Bye.